Trigonometry 1, the Pythagorean Theorem. The Pythagoras theorem is well known for strictly solving for missing sides of a right-angled triangle. You must know the length of two sides in order to use the Pythagorean theorem. So the Pythagorean theorem is dealing with right-angled triangle, and the sides are labeled A, B, and C. So no angle is necessary, just sides, and you must have the values of two sides in order to solve for the third side. The hypotenuse is always called C. The 90 degrees box is always pointing to the hypotenuse. The hypotenuse is always opposite away from the 90 degrees box. So here you have an example, the Pythagorean theorem. Calculate the length of the side L. Now L happens to be the hypotenuse. Okay, so as you can see, we have to write down your observations. You can clearly see the first observation is the type of triangle is a right angle triangle. The length that we want to find, the length of the letter, we have to describe it. It is the hypotenuse because it's away from the 90 degrees. So L is the hypotenuse, which is given the letter C in the formula. 3 and 4 now are opposite and adjacent sides. So the opposite and adjacent sides, or you can call them A and B. So 3 and 4, sides 3 and 4 are basically the A's and B's, okay? All right, so since there are two sides and no angles, we must use the Pythagoras theorem. Now the Pythagoras theorem says C squared is equal to A squared plus B squared. Now C now is L, so we substitute L in the place of C, so L squared is equal to 3 squared plus 4 squared. And 3 squared plus 4 squared is 9 plus 16. That's 25. So L now is the square root of 25, which is equal to 5. So let's do an example here. Let's transfer this triangle. So before we just dive into solving the triangle, trying to solve for R, we need to list some observations to know which formula to use. So first, we can see it's a right angle triangle. So we write that down. It's a right angle triangle. The next recommended observation is to describe the side that has the letter. Try to get to know what side it is. So since there are no angles present, R must be either A or B. Okay, so let's call R A. R is not the hypotenuse. The hypotenuse is always away from the 90 degrees. The hypotenuse doesn't touch the 90 degrees. So R could be either A or B. So let's call R A. R is equal to A. Or B, let's call it B. Now we can call it A. And obviously 24 is the hypotenuse. So therefore, we must use the Pythagoras theorem to solve for R. Small r that is, And by now we should know the formula is C squared is equal to A squared plus B squared. As seen, the Pythagoras theorem formula is not in the list of formulas that CX is going to give. Okay, volume of prism, volume of cylinder, volume of right pyramid, circumference, 2 pi r, arc length, area of circle, area of sector, area of trapezium, quadratic equation, the trigonometric ratio, sine, cosine, tangent, area of a triangle, 3 formulas, sine rule, cosine rule. So the Pythagoras theorem is not there in the list. So this is a formula that you must memorize. the Pythagorean theorem. A squared is equal to c squared plus b squared, where c now is the hypotenuse. Now we have clearly identified all the sides, so 24 will be substituted in the place of c. In the place of a, we can put 8. And in the place of b now, we can put r. So that's one of the main uses of the observations. It facilitates the substitution. So we have to find what is 24 squared and 8 squared. So 24 squared is 576, 8 squared is 64. So now we're going to cancel out 64 now. We'll try to solve for r. So r is already positive on the right side, so we leave it there. So we're going to subtract 64 on both sides, cancel out 64. Subtract 64 on the right, subtract 64 on the left. So we are left with r squared on the right. R squared is equal to, we have to find out what is 576 subtract 64. That's 512. And now to cancel out this square, we have to square root r squared on both sides. So as shown, we have to cancel out this square, the exponent of 2, we have to square root. So if we square root on the right, we go to square root on the left. Okay, so I left with r alone now on the right side. Is equal to the square root of 512. We have to find the square root of 512. So r now is equal to the square root of 512, which is 22.627 to 3 decimal places. So here's an example how to use the Pythagorean theorem to solve for r, one of the sides that is not the hypotenuse. So when you're solving for the hypotenuse, you have to be subtracting because the formula is made subject for the hypotenuse. C squared is equal to a squared plus b squared.